Let's sketch the Lewis structure of HCN, commonly known as hydrogen cyanide. To accurately depict the Lewis structure of HCN, follow these steps. First, start with a rough sketch. Then, illustrate the chemical bonds between the atoms. Next, identify and mark lone pairs on the atoms. Ensure the central atom and others achieve a complete octet. Finally, conclude by calculating formal charges, aiming for a stable Lewis structure with the least possible formal charges. Prior to sketching the rough diagram, initiate the process by calculating the total number of valence electrons and then identify the central atom. The total valence electrons in HCN are determined by summing the valence electrons of each atom. Hydrogen, a member of group 1, provides 1 valence electron. Carbon, from group 14, contributes 4 valence electrons, and nitrogen, a group 15 element, adds 5 valence electrons. With 1 hydrogen, 1 carbon, and 1 nitrogen atom in HCN, the total valence electrons calculation is 1 for hydrogen plus 4 for carbon plus 5 for nitrogen, resulting in a total of 10 valence electrons for HCN. When determining the central atom for HCN, consider positioning the element with the lower electronegativity at the center. In the case of HCN, hydrogen is present. However, considering hydrogen as the central atom is not valid, as the central atom typically forms bonds with at least 2 other atoms. Since hydrogen generally forms single bonds due to having only 1 valence electron, it is less suited for the central role. Therefore, in the case of HCN, the choice narrows down to carbon and nitrogen, the less electronegative of the two. With a carbon electronegativity of 2.55 compared to nitrogen's 3.04, carbon is selected as the central atom. It is placed in the center, with hydrogen and nitrogen atoms positioned on either side. A single chemical bond is represented by 2 electrons. Hence, position 2 electrons on the left side to signify the chemical bond between carbon and hydrogen. Similarly, place another 2 electrons on the right side to denote another chemical bond between carbon and nitrogen. In this way, out of the 10 total valence electrons, 4 are utilized, leaving 6 electrons unutilized. Lone pairs consist of electron pairs not involved in chemical bonding, and each pair comprises 2 electrons. With 6 remaining electrons, 3 electron pairs can be formed and marked on the structure as lone pairs. It's also essential to note that hydrogen, a period 1 element, cannot hold more than 2 electrons in the valence shell. Additionally, both carbon and nitrogen, being period 2 elements, cannot accommodate more than 8 electrons in their valence shell. Another important point to remember is to always start marking lone pairs on the outside atoms first and then on the central atom. In HCN, the outer atoms are hydrogen and nitrogen. Hydrogen cannot accommodate more than 2 electrons, so it won't receive any lone pair. Instead, we will assign the 3 lone pairs to the nitrogen atom. The hydrogen atom satisfies the duet rule, and nitrogen adheres to the octet rule. However, the central carbon atom's octet is incomplete. Let's now concentrate on completing the octet for the central carbon atom. First, recall that carbon is a period 2 element and cannot accommodate more than 8 electrons in its valence shell. Carbon initially possesses 4 valence electrons and needs 4 more to complete its octet. To achieve this, we will transfer 2 lone pairs from the nitrogen atom to the carbon atom, forming a chemical bond. After this adjustment, both the central carbon atom and the outer nitrogen atom satisfy the octet rule. Additionally, for hydrogen, the duet rule is fulfilled. Therefore, our next step is to check the stability of the structure by calculating the formal charge. This is the formula we can use to calculate formal charges for the HCN Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and place the values to derive the formal charges for each individual atom. For hydrogen atom, valence electrons equals 1, non-bonding electrons equals 0, and bonding electrons are 2. So the formal charge will be equal to 1 minus 0 minus half times 2, which equals to 0. For carbon atom, valence electrons are 4, non-bonding electrons equals 0, and bonding electrons are 8. So the formal charge will be equal to 4 minus 0 minus half times 8, which equals to again 0. For nitrogen atom, valence electrons are 5, non-bonding electrons are 2, and bonding electrons are 6. So the formal charge will be equal to 5 minus 2 minus half times 6, which also equals to 0. The formal charges of all atoms are marked, and it is clear that the current structure is stable, with formal charges on each atom being 0. Therefore, this structure is the preferred stable Lewis structure of HCN. To depict a pair of bonding valence electrons, use a single horizontal line. Since there is one pair of electrons on the left, draw one horizontal line. On the right side, where there are 3 pairs of electrons, draw 3 horizontal lines. This signifies that carbon is single bonded with a hydrogen atom and triple bonded with the nitrogen atom. So that's the Lewis structure of HCN. If this explanation helped, press the like button, share this video, and subscribe for more chemistry content.